Alright, so in Chapter 13 we're going to be looking at the design of different studies. And mostly what we're going to be doing in that chapter is setting up experiments and how we would design those. So the first thing that you have, though, the first delineation in the chapter is there's a difference between the types of studies, and one is called an observational study. Now, an observational study is basically a study where we do not impose a treatment on the subjects. So, for instance, if we were to study the impact of people who smoke cigarettes, well, we didn't have them smoke cigarettes. They did that on their own. They chose to do it. So all we did is observe the effects of what smoking can do, and we can create certain associations based upon that. Okay, as opposed to an experiment where we would impose a treatment on the subjects. Okay, and that could be a case where we design an experiment where we have students go to a study hall, and they get 2 hours of extra help after school from teachers, and we have another group that doesn't go to the study hall, and we observe the impact of the extra help versus the group that did not have extra help. So we told them to go for the extra help. We set it up. So therefore we imposed a treatment on these people. So that would be an example of an experimental design. Okay. The limits of observational studies is the fact that since people self-select themselves into these groups, we cannot prove cause and effect. And there was no greater instance of that than in the 60s. The federal government went after the cigarette industry. The cigarette industry, basically what was happening is all these people were getting lung cancer because smoking was socially acceptable and everybody did it. And the federal government went after the cigarette industry, and they wanted to hold the cigarette industry liable. And the cigarette industry said, well, not so fast. All you can really prove is that there's an association between people who smoke and people who get lung cancer, but it could be due to other factors. Let's say the people who smoke also eat a certain type of food, let's say junk food. You could say, well, the cigarette industry could say, well, junk food caused lung cancer. So what happened is the cigarette industry basically won their case, and they just had to put a sticker on the side of their cigarettes, but they were still able to continue selling cigarettes, just warning people that there was a sticker that said, smoking cigarettes could be detrimental to your health, but they never owned it, and it wasn't until a couple decades later that they were actually held liable, because there were experiments that were done not on human beings but on in labs on small animals. Okay, so in there's two types of studies. There's retrospective, and retrospective studies look in the past. So our smoking example is an example of a retrospective study. People who smoked tend to get lung cancer. Okay, so what we can do with that is make an association, but we cannot say that smoking causes lung cancer. Okay, prospective studies, on the other hand, look into the future. Okay, so let's say that we get a group of students in, and we want to see what the impact of house is. So we sit there and we watch a group for 4 years, and we want to see if it helps certain at-risk groups to make better decisions. So we implement house when they're in 9th grade, and we watch them for the next 4 years and see the types of decisions they make over the next 4 years. Okay, so that would be prospective. So retrospective looks in the past, prospective looks into the future. However, neither one can prove cause and effect. All right. right, so the whole purpose of doing experimental design is this whole thing about cause and effect. We want to prove that a certain variable causes an effect. So for instance, we come up with a blood pressure medication. We want to prove that our medication, in fact, does lower blood pressure. Okay? So that's the whole purpose of experimental design. It's to prove cause and effect. Okay? Now, the only problem with that is there are other factors. So we say, okay, well, we want to prove that our blood pressure medication lowers people's blood pressure. Well, there are other factors that could be could contribute to a person's blood pressure. Okay, their age. All right. Suppose people over 50 tend to have high blood pressure. Okay. The amount of stress in their life. You know, people who live in or work in a very stressful environment may tend to have higher blood pressure. Their diet. Okay. People who eat less junk food will tend to have lower blood pressure than people with a poor diet. Genetics, okay. You know, heart problems tend to be hereditary. You know, and you know, if you have a heart problem, that could be an issue with your blood pressure. Okay. Could be gender, males and females. Okay, males and females may get high blood pressure differently. Okay, depending on other variables. Okay, exercise. You know, people who don't exercise will tend to have high blood pressure. People who do exercise will tend to have lower blood pressure. So you see all those other factors on the bottom of this diagram. There's a ton of other factors that we have to account for when we're testing our medication. Okay. Okay, here's a little diagram of the experimental design process. It's just an overview. You know, we have a problem. So, okay, people have high blood pressure. We want to determine the objective. Well, we want to lower their blood pressure with our new medication. So we brainstorm and we come up with a medication, and then we design an experiment. So what do? We go down to a local hospital. Well, first we would get our product approved by the whatever group we would have to, probably something through the FDA, where we would have to be approved to do an experiment, and then we would go down to the local hospital and find some subjects with high blood pressure and administer our medication, and that would bring us to step 5. So we would conduct our experiment, then we would analyze our data. Did it in fact lower blood pressure, yes or no? And we would interpret those results, and then step A, we would then replicate it. So we would go either back into the hospital, or we would go to more hospitals and see if we can replicate our results. And in fact, are our results consistent? Does our medication consistently lower people's blood pressure? Okay. All right. So the 3 basic principles of experimental design. Replication's up on the top, and that is if we do an experiment, just because it works once doesn't mean that you know, we found the golden egg. We had to go and then replicate it. So we would do our experiment over and over and over again to verify our results and to make sure that our results are consistently happening before we would go and market something as an effective drug. Okay. It doesn't have to just be with drugs. I mean, it could be, you know, if we were doing our experiment with students after school. You know, all of a sudden we do 2 hours of extra help three days a week, and we notice that students' GPAs are rising. Okay, well, does that mean that 2 hours after school 3 times a week causes that to happen? Well, it could, but it could be other factors. Okay, maybe we had a good group of students. Okay, so we would then replicate our results and maybe even go to different schools and see if those type of results work before we went and published something in a magazine saying that all you got to do is give kids 2 hours of extra help and that'll raise everyone's GPA. Okay. On the bottom left you see that randomization, and the whole key to randomization comes back to this slide right here. Nope, that one right there. Those other factors right there. When we assign people to treatments, people come in with a myriad of other factors, be it age, gender, background, genetics. Okay, so you have all these other factors that are going to contribute to the results of your experiment. And you can't possibly control every variable in the experiment. Okay, it's impossible. Okay, so how do you account for all these other variables that could be contributing factors in your experiment? Is you randomly assign your subjects to treatment. Okay, so when you have your subjects, you put their names in a hat and you pull out, I don't know, the first 10 and they go to group 1 and the other 10 go to group 2. And by randomizing that, you're allowing for all of these other factors to kind of be blended in, even though you may or may not know about them, and I'll go into that in a minute. Okay, so randomization. It's very important that you randomly assign your subjects to treatments. Okay, now randomization is not randomly selecting your subjects. If we're doing high blood pressure medication, we don't go and randomly select people off the street, because the people that we're interested in are people who have high blood pressure. Okay, so that's the group we're given. If they come in with high blood pressure, we randomly assign them to treatments. Okay, that's very important. Okay, and then that last part is control, blocking, or stratification. Okay, so suppose that in our blood pressure experiment that we notice that gender is a factor in our experiment. Okay, for some reason the medication tends to work better for males than females. So what we would do is we would then put males and females in homogeneous groups before we randomly assign them. That's called blocking. So the first thing we would do is, let's say we had 100 subjects, we would divide them between males and females. And then within each of those groups, we would then randomly assign them to treatments from those two groups, and then we would then see what then happens as we conducted our experiment almost separately. Okay, we would be doing really one group for males and one for females. Okay, so next slide. Here's just a slide on how to set up an experiment. Very simple. So you got your subjects, you randomly assign them. Okay. So they get a treatment group and a control group. All right. So there's an effect out there that's known as the placebo effect. And the placebo effect is an effect when people are being treated for something, they psychologically think they're getting better. So what we're going to do is, with our high blood pressure group, is we're going to make sure that everyone thinks they're getting treated, even though half of them are not getting treated. Okay, so what we're going to do is we're going to give, let's say we haven't blocked or anything yet, but let's say we have 50 volunteers. We're going to randomly select 25 of them. Okay, they have high blood pressure, and those 25 are going to get our medication. Okay, the other 25 are also going to get a medication, but the medication is going to be what we call a placebo. okay, and they're really not getting treated, though they think they are. Okay, and then at the end, we're going to measure the effects. So we're going to say, okay, let's see what happened to the blood pressure of our group, and let's see what happened to the blood pressure of the control group. Okay, now there is a question here, and the question is an ethical question. Obviously, blood pressure is not immediately life-threatening, so when people go through the experiment, you know, we might have them do it for 10 weeks. And then we may say, okay, at the end of the 10 weeks, you're going to go back to your doctor, and then, you know, their doctor is then going to prescribe them an effective treatment or a different treatment, you know, okay? But that's the whole key there is in that control group, just understand that they're a baseline. They're for us to compare our medicine to, and we're going to see if our medicine works better than the group that didn't get treated. Okay, here's a classical experimental design. Okay, so what we do is we bring our group in, we divide them in half randomly. Okay, and there's a treatment group and a control group. So we send them, or we have them come into the hospital, and they get their blood pressure measured, and then they get their treatment. Now the treatment group gets an actual treatment, and the control group gets a fake treatment called a placebo. And then what happens is 10 weeks later, we have them come in, and we do what's called a post-test, and obviously they would come in and get their blood pressure taken again. And then we would compare those results and see, you know, what happened in terms of blood pressure, you know, if they got a treatment or if they did not get the treatment. Okay, now here's a block design. So what happens in a block design now is we got to put people in homogeneous groups first, because those homogeneous groups, there's some variable out there that we find is what we call confounding our results. And that is, we believe it's a variable that's contributing to the effectiveness of our study. So in this study, obviously, gender is a contributing variable. Okay. Now in this first part right here, see how we went from 1,200 subjects to 600 men and 600 women? That is not randomly done. Okay, that is done on purpose. It could be done by age. This group up here could be people over 50. This could be people who are 50 and under. Okay? Whatever that variable is that we feel is a contributing factor in our results, we're going to put those people in homogeneous groups first. And then what we do is we do random assignments. So the 600 men are then randomly assigned to two groups. Okay, 300 of them get a treatment, and 300 of them get a placebo. And then down here you see the women. Okay, random assignment. Okay, now they're randomly assigned. So we put 600 names in a hat, pick out 300. First 300 get the treatment, the next 300 get a placebo. We then compare results within the group. So I compare this group to this group and see, was there a difference for men? And I do the same thing for women. I don't do it across groups. Okay? So that's an overview of designing studies. So we, you know, keep in mind the difference between observational studies and experiments. Okay, who assigned the treatments? Okay, if you assign the treatments, experimental design. If it was self-selected, it's an observational study. And then just the general things in designing an effective experiment. Alright, so let's talk about observational studies. So if we want to observe individuals and record data without any interventions, we conduct an observational study. So we've talked about this. Observational studies that can look at data that has already been collected. These are called retrospective. That's a retrospective study. That looks into the past. Or it can look at data as it occurs, called a prospective. And that looks into the future. Observational studies are valuable for discovering trends and possible relationships, also called associations, but they cannot demonstrate cause and effect relationships. Okay? So, one thing to keep in mind is that people who are put into different groups are self-selected. They select themselves for groups. So if we're looking at smokers, they chose to smoke. Okay? You look at people who drink coffee every morning, well, they chose to drink coffee every morning. We didn't give them the coffee to drink. Okay? So in the 1960s, the U.S. government observed that people who smoked tended to die of lung cancer at a higher rate than people that did not smoke. Okay, so that is a retrospective study. All right. Then number 2, a team of school administrators observed the impact of not having sugar-based snacks available to students and noticed that students tend to get better grades. That would be a prospective study. All that we could prove in both of these cases is that there's a strong association. We cannot prove that that smoking caused this or that sugar-based snacks caused this either. All we can say is there's a strong association between what we're looking at and the result that we found. Alright, so let's talk about experimental design. If we want to examine cause and effect relationships, and that's what we're looking for here, this right here, you must conduct a controlled experiment rather than an observational study. The individual on which the experiment is done are called experimental units. If the units are people, they are called subjects. Okay? The experimental condition we apply to the unit is called the treatment. So in our blood pressure experiment we've been talking about, we have subjects because they're people. The treatment is the blood pressure medication. The explanatory variable causing a change in the other variables are called factors. Well, what's the factor in our experiment? It's the blood pressure medication. The factors may be applied in different levels. Okay, so we could have people take 2 pills a day, one in the morning, one in the night. We could have them take it once a day. We could vary the dosage. Okay, we could have one group take 250 milligrams a day and the other group take 500 milligrams a day. And then there would be the control group who gets 0 milligrams per day. Okay, so whenever you vary the quantity of the treatment or the factor that you're applying, then you are changing the levels. Okay. When designing an experiment, we want to minimize the effect of confounding variables. These are variables that might contribute to the results of our study other than the variable that we're studying. So the variable that we're looking at. Okay. Because we may not be able to identify and eliminate all confounding variables, it is essential that we use a randomized design. Randomization controls confounding variables. Okay. The control group gets either no treatment or a fake treatment called a placebo, and that's to counter the placebo effect, and that's the effect that people have when they're getting a treatment. They think they're getting better regardless of how effective the treatment is. Okay, just the fact that they're getting attention in some cases could could help them to feel better. Okay. Having a control group, that's the group that gets the placebo, allows us to compare the results of the treatments to a group that was subjected to the same environment except for the treatment that was imposed. Okay, so in our blood pressure experiment, we have a group that's getting the medicine and the group that's not getting the medicine. So everything else is the same except that factor, okay, that we're implementing. Okay, so here's experimental design. We have to control all known sources of variation. We're trying to only isolate the variable that we're studying, so we control all other variables. We block if necessary. So if we find that there is we know that there is a variable that's contributing to our results, then we would block. So if gender contributed to our results in our blood pressure study, then we would block by gender. Suppose it was exercise habits. You know, there's a group that does exercise on their own, and there's a group that doesn't. Well, we would block the group that exercises from the group that doesn't exercise, and then see the effect of our medication on both groups. Step 2 is we randomly assign experimental units and subjects to treatment. Note that experimental units and subjects are not randomly selected. They are randomly assigned, okay, for the experiment. Always have a control group. Why do you have a control group? Because that's your baseline group to compare your results to. Okay. And then we're going to replicate our results to verify. Okay, so if what we do works with one group, go and get another group and make sure that you get the same types of results consistently, and then you know that you have something that's effective. So remember, if we want to examine cause and effect relationships, we conduct an experiment. And the whole point of experiment is to control all known variables and to impose the variable that we're looking at. Not have people choose to use the variable that we're looking at. If an experiment is well designed, meaning all lurking variables are controlled, okay, any statistically significant differences in the data that can be replicated imply causation, which means that the variable that we are studying caused the results to happen. Okay. Now, here is how you're going to set this up for the AP exam. So this is all about the AP exam. Okay. This is in real life what we would do in doing experimental design, but here's what we got to do on the AP exam. We have to identify the subjects or experimental units. Specifically, not just say, well, there's 500 people. Okay, we would say there's 500 high blood pressure patients. Okay, specify how you will randomly assign subjects' experimental units to treatments. This is probably the biggest problem where students don't do well. They'll put down on their paper, we randomly assign 250 to get the blood pressure, and the other 250 will get a placebo. That doesn't specify how we're going to do it. How are you going to randomly assign? You have a few options. Put the 500 names in a hat. Select the first 250, they get the medication, the other 250 don't. You specified it. Number each patient from 1 to 500. Randomly select the first 250 using a random number generator and ignoring all repeats, and then the other 250 will get the placebo. You got to specify how you're going to do it. Okay, be very careful. Do not say we're going to put them in alphabetical order, and every other person is going to go and get the treatment, and you know, starting with the second person, and then starting with the first person, every other person is going to get the placebo. That's not random. Okay, you got to have some kind of a selection process where people are randomly selected. Okay. Identify factors, levels, and treatments. Treatments are a result of your factors and levels. Okay, and what I mean by that, I'll explain that in a second. Treatments equals factors times levels. So let's say our blood pressure medication, we could do it a couple ways. Okay, let's say that one group is going to get 250 milligrams, and the other group is going to get a placebo, so they get 0 milligrams. Well, what is our factor here? Well, it's the medication. That is the factor that we're imposing. So the medication is the factor. Well, how many levels are there? There's 2 levels. So what are the treatments? The treatments, there are 2 treatments. Okay, either they'll get a 250 milligram dose or they'll get a 0 milligram dose. Okay, we could do another one. We got the medication. We're going to have one group get 200 milligrams a day, another group's going to get 400 milligrams a day, and the other group's going to be the control group. What's the factor? It's the medication that you're imposing on people. How many levels are there? There's 3. 200 milligrams, 400 milligrams, and 0 milligrams. How many treatments are there? There's 3 treatments. 1 factor times 3 levels equals 3 treatments. What are the 3 treatments? People will get a 200 milligram dose, or a 400 milligram dose, or a 0 milligram dose. Okay? You have to specify that. Specify how you will measure the results. In our blood pressure medication experiment, we would give a pre and a post test, and we would see if the medicine was effective in lowering blood pressure. Okay? But you must specify, not simply say we're going to compare. Compare is not specific enough. Okay, so you have to specify how you will measure them. Alright, so let's look at some other factors. Okay, we have confounding variables. And these are an extraneous or outside variable that may affect the results of our experiment. And we talked about these. Okay, gender, age, dietary habits, heredity. Okay. And then the placebo effect. And the tendency of subjects to respond to being treated and not necessarily the treatment itself. So the fact that people are being treated psychologically could cause them to think that they feel better. Okay, types of experimental design. So we have a randomized design. All subjects are randomly assigned to treatment groups. Subjects, in most cases, are volunteers and are not randomly selected. They're randomly assigned. So the randomization comes when subjects are randomly assigned to treatment groups. Okay. So what does that look like? Here's what it looks like. You got your subjects. I'm just going to put 100. You randomly assign 50 to get a treatment, and then 50 to get a placebo. And then you would compare the results. So that's a randomized design. Okay? In a blocked design, subjects are first split in a homogeneous group called blocks. Subjects within each block have some common characteristic, okay, or variable. We'll say variable. Then within each block, subjects are randomly assigned to treatment groups. Alright, so what does that look like? Well, now we got our 100 subjects. Let's say we got 60 males and 40 females. And notice I didn't randomly assign those. They're already male and female. I had to randomly assign them. Now I randomly assign them within each block. So I'm going to have 30 males get the treatment, 30 get the placebo. This is randomly done when I assign them the treatments, and then with the females, 20 get the treatment and 20 get the placebo. And this is randomly done. And then I compare within each block, not across blocks. So I see how effective it is for males, and I see how effective it is for females. Okay. So that's blocked design. And then the last one is a match paired design. There are two treatments, but each subject is their own confounding variable. Okay. In each block, there is either a group receiving both treatments, or a group receiving one treatment first and then the other. Okay. All right. So, when do we use match paired? Let's say that we're doing we're testing a cleaner for contact lenses. Okay, so we want to see, we think we've developed a better cleaner. Well, how each person uses their contact lenses is going to be different from person to person. So each person is really their own confounding variable. Okay, so if I had 100 people, I could design this one of two ways. I could either, I can have 50 people get the new in the left eye, and then 50 people would get the new contact solution in the right eye, and I would randomly choose which person went to what group. Okay, so I pull their names out of a hat. The first 50 get the new contact solution in the left eye, and then the next 50 get it in the right eye. And then at the end, I would then evaluate. Okay. However, I'm evaluating within each of these groups. Okay, I'm gonna evaluate the whole group. The other way I could do this is I could say, okay, I'm going to give you this solution for 2 months. You would do 50 people do the left eye first, and then the right eye. And then 50 people will do the right eye first, and then the left eye. And let's say that this is going to be 1 month here and 1 month here. Okay. And I would randomly assign which person went in each group. You know, I would randomly select the 50 people, and then I would evaluate. Okay. I tend to use this design right here. So whenever I have a person and I'm going to they have something in pairs, and I'm going to try to see how it works on one thing as opposed to the other. So it could be hands. If I was testing gloves, I might do the new glove on one hand, the old glove on the other hand. If it's in their ears, I might see how something works in one ear compared to the other. I would do a match pair design. Feet. Okay. Arms. Anytime I'm doing something where each person could kind of be their own confounding variable, I want to do one treatment on each. Okay, so just keep that in mind as we're designing experiments moving forward. Okay, so tools to combat compounding variables and the placebo effect. The first one is blocking. Okay, and blocking is homogeneous grouping of subjects or experimental units to reduce the impact of a confounding variable. Blocking occurs before subjects or experimental units are randomly assigned to treatments, and we've already talked about variables. Gender is a popular one. Age is a popular one. Okay. Some kind of habit, whether it's their exercise habits, could be their dietary habits. Okay. They drink coffee in the morning, they don't drink coffee in the morning. Anything that we feel that could be contributing to our results, we would block by it. Okay. Then the next thing is the placebo. And that's a false treatment to control confounding. In many cases, I'm going to put in most cases, this is our control group. So those people think they're getting treated, so the fact that they think they're getting treated, everyone thinks they're getting better. Okay. Then we have blinding, single and double blinding. And single blind means that the subjects and administrators or the evaluators are blinded to the fact of who's getting what. Okay, so when we look at this, on one side of the experiment, you have the people who are being treated, those are the subjects, and the people who are administering the treatment. So suppose we have, in our blood pressure medication example, we have people who are going to the hospital. And we have them go to the hospital to, let's say it's an injection. Okay, they have to get an injection. Sorry, there it is. Okay. So if they go to the hospital to get the injection, if the people who are administering the injection know which one's the real one and which one's the placebo, they may treat the people differently. Okay, they may have conversations. They may give them literature. Oh, look at this new this article I found on lowering your blood pressure by doing these 5 different habits. It could be, you know, exercise, diet, such and such. So they give them the literature. But the people who are getting the placebo, they don't give them the literature because they're like, well, you know, they're not getting a real treatment anyway, so what does it matter? So that could confound our results. So we don't want these people to know who's getting what. The subjects themselves are blinded. They know they're getting a treatment, but they don't know if it's a real, they think it's a real treatment, but half of them are getting a real treatment, half of them are not. Okay, so this is one side of the experiment. The other side is the evaluators. Now, let's say that we have each person go to their doctor and get their blood pressure taken before and after. And if the doctor knows who's getting what treatment, the doctor again may treat the people differently. Okay, when they walk in, he may give them some information to help them reduce their blood pressure if he knows that they're getting a treatment. So we may not want him to know, or her, who's getting what, because they may confound our results. We don't want them to confound our results. Okay, we don't want anyone to know who's getting what treatment other than us. Now that brings up another key thing. Okay, because we blind this group or this group or this group and that group, by the way, that's called double blinding. If you blind this group or this group, that's called single blinding. You blinded one group. If you blind both groups, that's double blinding. That doesn't mean that no one knows what's going on. We know what's going on. The people who are running the experiment know what's going on. So someone knows what's going on. It's just that we don't want these parties that are involved to know. Okay. So double blind means subjects, administrators, and evaluators. So this is party 1, this is party 2. So 1 or 2, single. 1 and 2, double. Okay. Now, observational studies versus experiments. We've talked about this. The difference between an observational study and an experiment is who imposes the treatment. The person running the experiment running the study imposes the treatment, then it's an experiment. Okay, if the person who's running the study, if the people who are being studied selected the treatment on themselves, then it's an observational study. Now, keep in mind that good experimental design means that you randomly assign the treatment. But let's say that you don't randomly assign the treatment, but you do assign the treatment. That's still an experiment. It's just a poorly designed experiment. The fact that you impose the treatment means that it's an experiment. Okay, now you may say, well, that doesn't necessarily mean that it doesn't imply good cause and effect. Well, when you replicated your results, you would use better experimental design. Remember, when you do an experiment, we set up one experiment, but these experiments are replicated time and time again in the real world to see if the results are consistent. In an observational study, the treatment is self-imposed. In an experiment, the treatment is imposed by someone other than the subjects being observed. That's the key difference in the two of those.